Okay, so here's some extra stuff that we didn't get to cover in the lecture today. It's really an application of this concept of friction to one of the kinematics type problems that we saw in the first couple of weeks. So you remember when we looked at circular motion, one of the key things that we were able to discuss in the lecture is the idea that the velocity when you're moving in a circle is always tangential to that circle. So that's why we've marked the velocity of this. So we've got some particle going around here. It's moving around the circle, so its velocity at this point is vertically upwards. And what we were able to determine and show in the lectures is that the acceleration always acts perpendicular to the velocity and indeed always acts towards the center of the circle. And this is why the velocity changes, because the acceleration is not constant. Okay, or rather, it's not constant in direction, so the velocity also changes in direction. So now that we know Newton's laws, we know that there must be some force which is causing this acceleration, because of course Newton's second law, states that the net force acting on a particle is equal to its mass times its acceleration. So given that we have an acceleration for uniform circular motion, that must mean that we have a net force. Moreover, that net force must be acting in the same direction as the acceleration, because this formula basically enshrines that fact. The direction is all going to come from the acceleration here. So we must have a net force which is acting towards the center. And so for a particle that's moving with constant speed along this circle, its centripetal acceleration, which is the acceleration towards the center of the circle, must be caused by some force. And it turns out that that force is in fact the law of friction. So what is the velocity? How is it related to the acceleration? And how then do we compute the force? Well, if you look back at your notes for the circular motion part of the course, we find that the acceleration of something moving in a circle is given by v squared over r, where r is the radius of the circle. So, okay, we have some radius here. That's that distance. Okay, and of course the direction of this is then perpendicular to v. That's the direction. So let's just say that's the magnitude of the acceleration for now then. So that's the magnitude of our acceleration. Can we now turn that into a force? So the force which is acting on this car that's going on this track, or this particle that's moving around the circle or whatever, is going to be given simply by m times v squared over r. Okay, it's just m times a. So this is the force which actually causes the motion. And if you think about the different scenarios that could be causing this acceleration, so what forces could be attracting this object which is moving towards the center? Well, it depends on the scenario. So if you have a car moving around a track, what actually is happening is that you have the wheels. Here's my very badly drawn car here. You have the wheels on the track, and where they contact the surface, you're going to get a frictional force, and the tendency of the car will be to kind of fly outwards. That's where the car kind of wants to move. But the friction on the tires actually pulls it towards the center. So this is why if you're going around a corner and the coefficient of friction suddenly changes, say there's like an oil slick or you hit ice or something like that, instead of going round the corner, you'll carry straight on because that frictional force disappears and you no longer accelerate towards the center. So for a car, the source of this force is friction. And that's what causes the circular motion. But you might also have a scenario where you have like a ball on a string. Okay, so somebody doing like a hammer throw, like a sort of Olympic event. You imagine you've got some string here, which is attached to like a bob, and that's executing circular motion. Well, the force here is provided by the tension in the string. Okay, so that's the source of the acceleration, and that's what keeps the ball moving in a circle. And again, if that force changes, so say that the string stretches or breaks, then the ball will kind of move, fly off in a straight line instead of continuing on the circle, because the acceleration, the force disappears, so the acceleration disappears as well. And the final one that you might see is like a satellite orbiting a planet. Okay, so you have say like Earth here, and you've got some satellite which is orbiting the planet. What's the source of the force there then? Well, then this is just the force of gravity. Okay, so this is the attractive pull of the planet on that satellite towards the center of the planet. That is the force which is providing the acceleration. So in all these cases, the force is acting towards the center of the motion, and that's what keeps these objects moving in their circular paths.